Good morning. I am S. Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology. Today I am going to take the topic on 8051 architecture and internal units under the unit 8051 microcontroller. So let us discuss about 8051 architecture. So 8051 microcontroller, it is a 8-bit microcontroller and developed by Intel Corporation in the year 1980. So it has a Harvard architecture which has a separate program memory and data memory, and this has been specifically designed for control based application, and this is entirely used for embedded systems and for robotics also. So initially this microcontroller was developed using NMOS technology, where later versions were being using with a complementary metal oxide semiconductor technology, which is CMOS technology, and hence the name Intel MCS51. So let us see about the architecture of 8051, and this is a simplified architecture of 8051, and it comprises of central processing unit CPU and memory in the sense ROM and RAM, random access memory and read-only memory, input output ports, and then timing and control unit. So 8051 is a 40-pin dual inline package which has a 4 KB ROM and 128 byte of RAM storage apart from 16-bit timer circuits also. It has a 4 parallel input-output ports that has been either programmable as well as addressable as per the user requirement, and has a crystal oscillator frequency ranges from 4 to 30 MHz, where this has been specifically designed for 12 MHz crystal oscillator frequency. So let us discuss about the elements of the microcontroller in detail. So first comes the central processing unit. Central processing unit executes a program instruction and controls all the operations within the microcontroller that is necessary for executing the arithmetic as well as the logical operation. So this acts as the brain of the controller unit. And next comes with the memory unit, random access memory and read-only memory. Random access memory, this holds the data that has been used for arithmetic and logical operation, and hence that storage of data will be for the temporary. And whereas the read-only memory, it holds the program code instructions to be executed for the necessary operation, and hence ROM act as a permanent program code memory storage register here. Next comes with the I/O ports, input and output port. This has been specifically used for interfacing with the external devices like sensors, LEDs, switches, stepper motors, interface circuit purposes also. Timers and counters. Timers and counters, this has been specifically designed for elapsing the time delays necessary for synchronization of the operations. And this has been also used in control applications like pulse width modulation circuits and waveform generations. Next comes the clock oscillator circuit. As we have seen, the crystal oscillator frequency here is about 12 MHz, and this provides a necessary timing signal for synchronizing the operations that happens inside the microcontroller. Central processing unit, it also holds a few registers and also the program status word data pointers. So what is that ALU? ALU performs arithmetic and logical operation, and the data necessary for this operations will be stored in the accumulator. It is an 8-bit registers, but this stores mandatory the necessary data during this AL operations. And next comes the B register. This along with this accumulator register, it is necessary for performing operations like multiplication and division, and this is also act as a temporary storage register similar to accumulator. And next comes with the program status word. Program status word, this reflects the flag bit or the status bits that is being performed during the arithmetic and logical operation. Also, this has been used for the register selection banks also. So this program status word, it holds the status of the carry flag, overflow flag and zero flag, and also this has been specifically used for bank selection also, whether bank 0 to bank 3, about which bank has to be selected. It depends upon the flag bit in this PSW. And next comes the status pointer. Status pointer, it always holds the top of the stack and what is the next operations to be performed that can be fetched from the stack pointer. Next comes the program counter. Program counter holds the address of the next instruction to be executed, and the data pointer is a 16-bit register which is being used for accessing the external data memory. Apart from that, we have seen the internal ROM acting as a program memory that holds the program code or instructions to be executed, and it has either code memory as well as the data memory. So data memory, this act as an internal RAM, and the external 64 kilobyte of memory can also be accessible here. And here it holds the general purpose register and special function registers also. Input and output ports, this is used for interfacing with the external peripheral devices, and timing and control circuit that has been used for providing necessary time delays for the circuit. And microcontroller has been utilized for manufacturing of appliances, embedded system, telecommunication equipment, and also in mechanical devices, motion sensors, and everywhere have been used. So we have discussed about the assessment questions in the video, so kindly refer that. Thank you.